Evaluate tangent of sine inverse of 3 over 4 minus cosine inverse of 1/3. With this type of problem, we can never use a calculator because the calculator will give us a decimal answer and we want the exact answer, even if it is not stated implicitly that we need to find the exact answer. We will need to show the work and evaluate this exact value. This is the tangent of the difference, and inside tangent we have two expressions of the inverse, so we let the first inverse expression be theta and the second inverse expression be phi. Then sine inverse of 3 over 4 equals theta and cosine inverse of 1/3 equals phi. We then rewrite it without using inverse function. Sine of theta equals 3 over 4 and cosine of phi equals 1 over 3. We cannot use theta for both inverses because we don't expect them to be the same. If we use inverse sine theta and rewrite it, then we need to restrict the domain. Theta has to be between negative pi over 2 to pi over 2, the endpoints is included. For cosine inverse, we would restrict phi between 0 and pi. 0 and pi are included. Up to this point, we rewrite this so that the first inverse is theta and the second inverse is phi. It remains, or it suffices to evaluate tangent of theta minus phi. If we can evaluate tangent of theta minus phi, then we are done. To do that, we will use the difference angle formula for tangent, which states that tangent of the first angle minus the second angle is tangent of the first angle minus tangent of the second angle over 1 plus tangent of the first angle times tangent of the second angle. We then find tangent of theta and tangent of phi. To find tangent of theta, we go back to sine of theta equals 3 over 4 and draw a generic right triangle. Sine is the opposite over the hypotenuse, so we label one of the acute angles at theta. The opposite is therefore 3 and the hypotenuse is 4. Sine is opposite over hypotenuse. Then we find the missing side. This is 4 squared minus 3 squared, then taking the square root, or 16 minus 9, which is the square root of 7. And we do the same thing for phi. We draw a generic right triangle and label the acute angle phi. This time though, it is cosine of phi is the adjacent over the hypotenuse. The side that is adjacent to phi is labeled 1 and the hypotenuse is 3. The missing side is therefore the square root of 3 squared minus 1 squared, or the square root of 9 minus 1, which is 8. But the square root of 8 is 2 root 2. We're now in the position to write the tangent theta and tangent of phi. Using the first triangle, tangent of theta is opposite over adjacent. Minus tangent of phi, it is the opposite over adjacent over 1 plus tangent of theta, using the triangle with theta, opposite over adjacent, times tangent of phi, which is 2 root 2 over 1. We still need to simplify this expression. But one thing we want to keep in mind is that how do we know that this is a plus the square root of 7, but not the negative? After all, tangent is positive in the first quadrant and negative in the fourth quadrant. We can narrow down the quadrant by looking at sine of theta. Sine of theta equals 3/4, which is positive. So although we restrict it into two quadrants, but since sine is the positive in this case, theta has to be in the first quadrant, meaning tangent has to be positive. For phi, cosine of phi is restricted from 0 to pi, and so we are restricted to the first and the second quadrant. But because cosine is 1/3 in this case, we restrict phi in the first quadrant, and in the first quadrant tangent is also positive. We now need to simplify this expression and we are done. This is the complex fraction, so we would need to take care of the numerator and the denominator separately. In the numerator, the common denominator is the square root of 7, so we would multiply the square root of 7 to the second term. 3/√7 minus 2√2/1 times √7/√7. In the denominator, the common denominator is also the square root of 7, so we multiply 1 to √7/√7, and we keep the second term, but we multiply them across. 2 times 3 is 6, 6√2/√7. We can now combine the numerators and the denominator separately because they have the common denominator. In the numerator, the common denominator is √7, and we simply subtract the numerator. 3 minus 2√2 times 7 is 14. And in the denominator of the denominator is √7, and in the numerator of the denominator it is √7 plus 6√2. This is 3 minus 2√14 over √7 times the reciprocal of the denominator, which is √7 over √7 plus 6√2. The square root of 7 cancelled out. The result is 3 minus 2√14 over √7 plus 6√2, and we are done. We don't need to multiply the conjugate or rationalize the denominator in this case.